Okay. Centers of mass. We're going to start off simple, and then we're going to get more complicated into like calculus stuff. Okay? Why is it not going? Okay. So what is the center of mass? How would you describe it to me?
It's like you can treat the object as if all of the mass were located at that point.
Okay, if I had an object and I put that object on my finger, where would I want my finger to be? The center of mass, right? We would be able to balance it there. Okay? Okay? The point where mass seems to be concentrated, okay, I think that was a good way to put it, Jackson. If the mass is of constant density, then we call the coordinate the centroid. Okay. As long as we have constant density, then we call it the centroid. And that's what we're going to work with today. Okay? Okay, so you see like an XY axis there. What do you think we're going to have to consider when we go to find the centroid? What different things should we consider? Area?
Is the object changing at any given rate at any time?
Well, the density is constant, but it could have like different, like do you see how I have like a 10 kilogram chunk, a 4 kilogram chunk, and a 6 kilogram chunk? Like we have constant density, however, our weight may not be distributed evenly amongst the object. Does that make sense? Okay, so we kind of need to figure out where the concentration is. Okay, like where is it heavier on which side, and how far are we away from the true center? Okay, so each mass has what we call a moment, and that moment is the product of the mass and the distance from the origin. So mass times distance. And in order to find the centroid, what we're going to do is we're going to take all of these moments and add them together, kind of like we're taking an average, right? But we're taking an average of basically its weight, okay? So we're going to take all of these moments and add them together and divide by the total mass, and that is going to give us our centroid. Moment over mass gives us the center of mass.
You have to do that in two directions then to actually get a coordinate.
We'll get there. We will get there.
What is the line of X?
Right now we're going to talk about just like a linear center of mass.
Like the average position. Or the average.
You guys haven't gotten to see my new projector, have you? Notice how bright it is? No, you notice? Yeah. Wednesday afternoon, I got a new projector. What?
There's no glare.
There is no glare. Well, it's also raining outside.
Maybe not all distracted.
What is Okay, so we're going to find the center of mass. We have 10 grams, 5 units to the left. We have 15 grams smack dab in the middle, 5 grams, 4 units to the right, and 10 grams, 7 units to the right. Okay, so I went ahead and put mine on a number line. Okay, with our 10 grams, 5 units to the left, we are going to call that position -5. Okay, our position at at the middle would be 0, and then we can use a +4 and a +7 for our 4 units to the right and 7 units to the left. Okay, so how do we find our centroid? We have to take our moments. Okay, our moments. So what is our moment for this first? Okay, -5 times 10 plus 15 times 0 plus 5 times 4 plus 10 times 7. And we divide by what? Total mass. Which is a nice number, isn't it? So we have -50 plus 0 plus 20 plus 70. And we're dividing by 35? 40? There's another 5 right there. I didn't get that 5 on this. Okay. So our center of mass is at 1. So whatever our object is, okay, we could balance it right here at 1. Okay, that's our center of mass. Okay, now you asked about the y coordinate, right? Okay, so what happens if we have a two-dimensional object, right? Where we have x distances and y distances to worry about.
Distance formula.
Not so much.
Oh.
Okay, so we already talked about this. Okay, what do those sigmas mean? Sum. So to find our centroid, we took the sum of mass times distance over the sum of mass, right? Yes? Okay. We notate this as the moment about y. What? Why is that the moment about y?
Because everything's a little more complicated than it ought to be.
Because it's with respect to the y-axis.
Oh, those are the distances from the y-axis. Doesn't x represent the distance from the y-axis?
Yeah.
Okay, so we call this the moment about y because all of those distances we talked about with this linear example, if I drew a y-axis in there, right, those are the distances from y. Okay, so when we're in 2 dimensions, mass times our x distance, that is the moment about y. Okay, and when we take the moment about y divided by the sum of our masses, okay, we get the x coordinate. So what do you think is going to be true about the y coordinate?
You just replace x with y.
Okay, you just replace x with y. Okay, so that is going to be the moment about x. All right, to where we're finding all of the distances from the x-axis, which we think of as y. Okay. Okay, and then of course you are also going to divide by the total mass.
Wait, why is it about the x-axis? Because the other one's with respect to the x.
This guy's with respect to the y-axis.
Yeah. So then,
So this guy's with respect to the x-axis.
but then it's about the y-axis. Does about and with respect to mean the opposite thing?
I don't know what you're asking, dude.
The moment about x.
Yeah. Is that just the one where you use axis?
Well, this is the moment about x, so it's our y distances from the x-axis.
But it just says centroid about y-axis. Is that? Oh, it's because it's the centroid.
Right.
And if
Okay.
you find that in conjunction with the x, is that just the equilibrium?
Yes, which is what we're going to do. Okay, you led me to my next thing. Okay, so like if we had a linear system, okay, but it was vertical, we would use this. Okay, if we had a 2-dimensional system, here's our x coordinate, here's our y coordinate. Okay. Okay, so consider the system with 10 grams. Doesn't that look like a log? Okay, I keep saying log. Like the font. We have 10 grams at 2, -1, 7 grams at 4, 3, and 12 grams at -5, 2. No matter which coordinate we're finding for our centroid, we know we need to take the moment over the mass. Okay. So what is our total mass? It's
29.
10 plus 7 plus 12, 29. Okay. So we know for sure that we're going to divide by our total mass. Okay. Now it's a matter of how do we put our moments together? For our x-coordinate, we're going to take the moment about y divided by the mass. The moments about y mean how far are we from the y-axis. How far is 10 grams away from the y-axis? 2, because that's the x-coordinate. So 2 times 10. Plus, how far away is 7 grams away from the y-axis? Okay, so we have 4 times 7. And how far away is 12 grams away from the y-axis? -5. So -12/29 would be our x coordinate. All right. Now, for our y coordinate, we're going to take the moments about x divided by mass. Our 10 gram coordinate, how far away is it from the x-axis? -1, because that's the y value. Okay? Plus, our 7 gram coordinate is 3 units from the x-axis, and our 12 gram coordinate is 2 units from the x-axis. So 35/29 would be that one. So your coordinate would be -12/29, 35/29. Yes.
So like if it was like 3-dimensional, then you would just do the same for like z. Like
Well, that's going to get a little bit more complicated because we would have to think about your distances from
are we gonna have to do that?
No.
Okay.
No. Let me think about that one. It seems simple, but yet complicated, right? Let me think about that one. Okay.
Can we do coordinate?
Okay, have we done any calculus?
No.
It's a good thing, right?
Let's do some calculus.
Thought we were taking a break from calculus today.
Can we
You thought so?
Yeah, I thought today was like
Yeah.
a flashback Friday or a memory Monday, but we're memorying back a long
Memory
time.
back.
Oh, I love that curve.
Okay. You love that curve?
Are you right?
Maybe my 5-year-old did draw it. Just saying. I don't think she did. Okay. So, consider a region of a curve with a material of uniform density. What's the problem here?
It's an ugly curve.
Yeah, obviously that's a pressing matter.
Okay. We're going to divide this into rectangles. Where is this going? We won't do a Riemann sum. We'll get to do an integral. Okay? Okay, we're going to divide it into rectangles. The mass of each is considered to be the centered at the geometric center. Okay, so we're going to think about, okay, in this rectangle, where's the center? Okay, the mass of each is the product of density and the area. We sum the products of the distance and mass. Essentially, we're gonna have to add all those up. Okay. So what we need to consider is how do we find the moments? How do we find the mass? And if we can take moment divided by mass, then we can find our coordinate, right? So the issue really here is how do we find the moment and how do we find the mass? Okay, but if we can take the area times density, then we can figure out the mass. Do you agree? Okay, and do we know how to find area? Okay, so as long as we can figure out what the density is, mass is under control. It's really the moments we're going to need to figure out. Okay. I'm just making sure everyone's getting what they need written down. Okay. Our activity tomorrow, I'm going to give you a region that you're going to have to find. You're going to have to cut it out, and you're going to have to prove to me that you found it the correct way. Okay. All right. So, whoa.
Okay.
No, I don't want that. I don't know how that happened. Okay. Our moments. Mass times distance, correct? Okay. Write it down, and then I'm going to talk about why that is.
Is that like a hyphen or a subtraction sign?
That's a subtraction.
Like for the bullet point.
Oh, the bullet
Yeah,
point,
I
that's
was
a
like,
hyphen.
I was like, what? That doesn't make sense.
Sorry. I was looking at the important one. Yeah, I can't.
I kind of want to write it down.
And I said,
If you don't want me to, I understand.
It says mine.
It says what? Oh, it's mine.
Stop. Why do you have like? What's that? What's that? Like I or something?
You set yourself up for that.
What is that symbol?
Row.
Huh?
Row.
Row.
What?
The P.
The P?
The P.
Oh.
Isn't that row?
I have no idea what it is. I'm asking you.
What is that symbol notating? Density. Okay. So what did we just talk about? Area times density is mass. Okay. So area under area between two regions.
Yeah.
F of x minus g of x. So this is your area times density. So there's your mass. And then the x from in any given rectangle is telling you how far it is from the y-axis. Do you agree? Okay. So x is the distance from the y-axis. Density times height. That's your area times density to give you mass. Okay. That one's nice to remember. Where it gets a little tricky is when we have to think about the moment of x, because we want to keep everything with respect to x to make our lives easier, right? So how do we describe the middle of each of those rectangles for your distance from the x-axis? How do you describe the middle of all of these rectangles for your y-coordinate?
F of x minus g of x over 2.
So very, very close.
Plus.
Okay, you would want to average the heights, right, to be in the middle. So that's what you're going to see here. You're still going to have your area times density for your mass, and then here is your distance. Mid function.
Wait, why are f of x and g of x still here?
Because I don't want to leave just yet.
Somebody kick
Okay, so f of x plus g of x over 2 replaces the x. Okay, I see.
So x, they're both signifying our distance from the center. Here is our distance from the y-axis. Here is our distance from the x-axis. And as we've been talking about, our mass is just density times area. So the integral of density times area. Now, do we have to know the density?
Kind of.
No. No.
Are we going to take moments divided by mass?
Yeah.
I mean, you
And
need
so when you do that,
They go away.
the densities are going to cancel
They're just
out.
numbers. We can
Oh.
shoot them away.
Okay. If I wanted the mass, yes, I would want the density. If I wanted just the moment, yes, I'd want the density. But if we're finding the centroid and we take moment divided by mass, those things are canceling out and it doesn't matter. Yes.
Could you, like, for the moment about x, could you, like, multiply the fraction times f of x minus g of x and simplify it to, like, f of x squared?
I'd see that.
Yes. Who else sees that? Okay. What is
No, I said that.
a plus b times a minus b? A squared minus b squared. So if you wanted to rewrite this to be density divided by 2 of f of x squared minus g of x squared, that would be equivalent. Now, I don't present it to you that way because I want you to see where all of this comes from. Why we have f of x plus g of x over 2 and why we have f of x minus g of x. But if you want to simplify it to that, you're more than welcome to. Okay, especially if you're going to do it by hand, right? With a calculator, meh, who cares? But by hand, you would probably want to simplify that. Okay, so with the remaining 10 minutes of class, we are going to do one example. You'll have your homework, and then we'll revisit this tomorrow with our activity. Okay? We're going to find the center of mass, the centroid, between the two curves, y equals x squared plus 16 and the x-axis, from 0 to 4.
F of x minus g of x is still just top minus bottom.
Yes. Yes. Still top minus bottom. So, okay. Let's do this. What do you want to find first?
Let's find the moment with respect to x.
The moment about x?
Yes.
Okay, so which coordinate is that going to help us with?
The x. That would be the y.
Mm-hmm. Do you still want to find that first?
No.
Okay.
It's not that complicated. It's only one function.
What? John asked you to take a time out from talking.
Gabe,
It's not that complicated, really.
Gabe. We don't even talk like that. You don't tell somebody they need to take a time out from talking. That is not. Okay. If our moment about y is density times x times f of x minus g of x, then we're going to take the integral from 0 to 4. I'm going to just throw density on the outside because I don't really care about it. X is our distance from the y-axis. F of x minus g of x would be x squared plus 16 minus 0. Okay, technically we could find this by hand, but probably not. moment about x, density 0 to 4. Each of our rectangles have a distance back to the x-axis of x squared plus 16 plus 0 over 2. And then for our area, we need f of x minus g of x, top minus bottom. Okay. And then our mass, density, 0 to 4, top minus bottom. Okay. I threw my density out in front because he doesn't matter. And I know that when we divide the two, they're going to divide out.
Should that be dx for the last one?
Well, didn't you see that?
I did not.
Yeah. Okay. So, just leave out the row and find me those three values, please. Use your calculator, let's save some time.
Row is
I think that's what it is.
We're working with density in physics right
Are you?
now. A little bit. Reactivity. Yeah, we just put
It's that,
he's
yeah.
in there. He's in one of the equations.
Yeah.
He's in. Okay, I think I got it.
Yeah.
What's our moment about what?
192.
192. Okay, I think I got the second.
Okay, what do you have for that one?
155.73.
Make that a nice fraction for me.
I don't know if there is a fraction for that. There isn't a fraction.
Really?
Yeah,
It's
yeah,
14
right.
It's 14,336. Oh yeah. Over 15.
Oh, okay. That's a normal fraction.
And then our mass.
Oh, that one's a simple fraction.
256 over
What, 56?
256.
I don't like this fraction.
Well, you have a calculator, so no. So our center of mass is going to be the moment about y divided by our mass. Look at that. Density cancels. Comma, our moment about x divided by mass. Density cancels. And we're left with the coordinate
Very big
56 over
fraction.
5. 9 over
56 over 5.
4. Is it not over 4? Maybe.
Yeah.
I did it in order.
9 fourths, is that what you said?
Yeah.
And then 56 fifths? Okay. Was that as bad as you thought it was going to be? The concept.
They were
Okay, the numbers weren't pretty, and they're not going to be pretty. I just tell you that right now.
Yes,
But
they
the
were.
concept.
They were.
Yeah.
Oh, you think they're
Yeah.
pretty?
They weren't.
Numbers
They were
don't
good
have
at
to
it.
conform to your
Makes sense.
Eventually.
You don't read ones
think
that
it's
don't
better
just
when it's like not.
It's said. It's not
All right, now, Victoria, we lose you tomorrow.
It's a
Yeah.
I know.
Like, you team stuff.
Act.
Why are you such a junior?